Hello, everyone that's joined so far. Thank you. I'm going to give it a minute more so because I see there's some people still joining. Then we will start. Right. Hello again. Thank you very much for joining. I see there might be a couple of people still to join us, but I think we will kick off. I'll introduce myself. My name is John Dunk. I'm a director of PFPNet and chair of the steering committee. So welcome to this webinar, Fire Protection in Road Tunnels. I'll first start off by telling you a little bit about what PFPNet is, for those that don't know. Primarily, PFPNet is a subscription-funded organization aimed at the users of fire protection systems in hydrocarbon processing, energy, and associated industries. It's run by the members for the members, and the overall objective of PFPNet is to increase knowledge, understanding, and improve quality and standards in this safety critical area. There are actually two PFPNets. One is PFPNet, the original organization, which is the subscription-funded organization. But we have recently started PFPNet eTech, and PFPNet eTech is the money-earning side of PFPNet aimed at training. And the reason we have done this is because we recognize there's a great need for training in passive fire protection. So we have started a training side of PFPNet and recently launched an introduction to passive fire protection in the energy industries online course. And we will continue to develop training as we go forward. Next slide, please, Jos. Yeah, so this gives you an idea of the membership of PFPNet. It's reasonably diverse. There's a couple of key companies missing off that slide, actually, Shell and Lloyd's Register. So it's a mixture of owners, engineers, suppliers, and others who are all involved in passive fire protection in this area. Next slide, Jos, please. So recognizing the similarities between tunnels fires and oil and gas fires, and that's primarily due to the severity of them. Some time ago, PFPNet formed a tunnels fire protection group, which is currently chaired by Kees Both of ETEX. And the group has developed several documents addressing fire protection in tunnels, most recently the guidance document, which we are going to be presenting during this webinar. Next slide, please, Jos. So, rules for the webinar today, please. No interruptions. Microphones on mute, please, and cameras off, please. Questions may be asked using the chat functions, and we will take a limited number of questions answered at the end of the presentations. All the other questions will be answered through mail, and when I close out this discussion, I will explain more about that. And also, I've got a couple of other items to put to you during that final discussion. So the order of the running is firstly, consequence of fire in tunnels, presented by Talal. Secondly, solutions and asset methods by Jos. And Kees Both and Ali will moderate the chat box going forward. And we've already done one of these today. That worked rather well. So if you have any questions, please put them into the chat box and we will attempt to answer them directly. Okay, so that's it from me. I'd like to ask Talal to start the first presentation, please.
Yeah, good afternoon, everyone. First of all, I would like to take this opportunity to thank John and thanks PFPNet for the opportunity to present ourselves and also to present our work, and the guideline will be presented by my colleague just later. To make it very easy, my presentation is very short. It will be really to introduce ourselves and also maybe to have the introduction for the second presentation. So I will not take a lot of time. I will try to do it in 10 minutes to give more time to my colleague and later for the question and the discussion all together. So if we'd like to start, just second one. Yes, I would like to take this opportunity to present ourselves. Effectis, what's the story of this group? So 20 years ago, a French research center, the Metallic Construction Institute, with the Dutch Public Research Center, TNO, created private company, name it Effectis. And this company, it's really dedicated to the fire safety science. At the beginning, we were working to cover the requirements for the fire testing, not limited to resistance, reaction, and the full-scale test. Later, the company extends their activity to improve and to address the need of the market. Next one. Today, after 20 years, the company has more than 300 staff. We are operating 19 locations across 5 countries. Today, we have 7 fire testing laboratories across Europe. According to our database, we conduct last year more than 10,000 fire tests. We are present in the UK, Netherlands, France, Italy, Turkey, and Spain. Next, just. How we work with our clients? Effectis can work at the product scale to assist the product with the manufacturer to address the need of the market, to trade that product in each country. We are able to provide the CE marking and UKCA and Effectis certified. It's our voluntary scheme. At the same time, we are able to assist the system in the real application. So what we call project assessment. So then we are looking at the full scale and the full application of that product or that system in a place. Next, Joss. As I mentioned, Effectis can cover the requirement for the fire testing. So we are able to perform reaction to fire, fire resistant, large scale test, and also we are able to provide certification across expertise and the inspection. And of course, we have a lot to do in the fire engineering and the fire simulation. Yeah, just. Here our area where we are working, we are covering several sections, not limited to public buildings or high-rise building, but also we are massively involved in the nuclear and the transport area and infrastructure and oil and gas. Next. If we would like to start with our topic today. As you may know, each fire is a specific scenario, so we cannot really investigate by the experiment alone each test. But as we are talking today about the tunnel fire, so let me use the word different, not complex or difficult to understand. Why is it different than the other fire? Just please a second. Because we have different factors can involve in this fire. As you may know, the ventilation, it's already there in that tunnel. So the oxygen, we are providing oxygen across the time during the fire. The fire can start in different location, which will change the scenario. And also it change the damage for that tunnel, the strategy to address that fire. If we're talking about the fuel load, there is no limitation in the fire in the tunnel. It can be a few megawatt if we are talking a fire starting with a car, where it can be hundreds or more when we are talking about a truck or maybe petrol tankers. We can have also what we call moving fire. If we are talking about tunnel where the train it's running across and we have a fire in that train. And also the tunnel itself has very specific situation because he has a consequence during the accident and also after. So if we'd like to start explore together what it is the consequence. After, next one. There is a lot to speak in this area, but I just take this opportunity to share with you and maybe remember you that what impact can have if we have a fire in the tunnel. So I will not cover all of them, just to have a few points quickly as an introduction for the next presentation. Just the next. If we start with the fire hazard, as you can see in the picture, a fire in the tunnel will generate a lot of quantity of the heat and also a lot of smoke. The smoke has a toxicity. We know that we can have different emission gases in that emission. However, we cannot come with the right formulation of that smoke. Why? Because the gas can be changed from one scenario to other, depending on the fuel combustion, the ventilation, all the element we discussed before together. And also we need to pay attention that always we have the risk to have the explosion somewhere in that smoke. Just another topic we need to cover when we have a fire in a tunnel, that we need to evacuate a lot of people may concern it or impacted in that fire. For some reason, when we are doing the training in normal day or any fire drill, and I believe a lot of us participate somewhere, somehow in evacuate training in their buildings, everything it's happened very smoothly, very quick, without any problem. But for some reason, when we are doing that in the tunnel, in the real case, we are acting in different way than the normal. It can be because we are following others, or because we have panic and we don't know exactly what we would like to do at the right time. This can lead to increase the evacuation time. Increasing the evacuation time can lead to increase the fatality or the injury cases in that tunnel or that accident. Just next. Of course, any fire in the tunnel will lead also, or may lead also to failure in the power system. It means that we are losing the lighting, ventilation, or maybe the communication. And also that we need to close that tunnel during the accident, and this can lead to traffic distribution. And also we may need to maintain that closing of that tunnel after and further to have our investigation, and maybe for longer time when we would like to have the repair and the maintenance before open that tunnel again. So just again. So the real cost for that accident is not only the cost of the maintenance of the reparation, but also we need to think about the alternative solution that we need to put in place during that maintenance work. So logistics may rise a lot or extra cost. And also we should not forget, and we need to pay attention about the pollution that we are doing during that fire. So we can mention pollution in the air or on the water. And something I would like to bring over the table here is that if we have several severe fire in tunnels, that we can lose the public confidence in the safety of the tunnel and the infrastructure. So one of the main damage during fire in a tunnel is the damage in the structure. And one of the main structural problem in the tunnel exposed to fire is the serious damage caused by explosive spoiling of the concrete. So we need to pay attention how this reacted during the fire. So I raised the consequence of the fire, but of course there is a solution. We can mitigate all this together. How? I just put here a few examples, not report everything. Good design, early detection, high maintenance, enhanced inspection, training the staff. All this can help. But of course, as we are talking today about the passive fire protection, this can be of assistance. Next one. So using the right passive protection will give us more support for the evacuation firefighters activities. And also, for sure, it will reduce the damage or the impact of the fire on the structure and our technical installation. What it means is that we are minimize the economy and social impact of that fire. And somehow it means that we are extend the design life or the cycle life or that tunnel. Before I close my presentation, I just want to add something to be considered for the future, for next research, that today our life is changed. We are using a new technology, and this technology may change the risk that we are dealing with, and we need to consider that in any further research activity. So I am just providing two examples. We are using now more and more electric cars, and also we start to see hydrogen vehicle or maybe a train, lorry. So we need to think how it will be the future. I believe I finish it. Thank you very much, and I will leave it with just now. Thanks.
All right, thank you, Talal. So we will continue with an introduction to the guidance documents on passive fire protection in road tunnels, with the emphasis on solutions and assessment methods. So my name is Jos Bienenveld, and I work at Effectus as a project leader at the fire engineering department. And my main involvement is in fire resistance of concrete structures, tunnels, protection of concrete structures. I'm a co-author, editor of the Effectus RO095 procedure for testing of tunnel lining. I'm also a co-author of the PFP-NET guidance document. Here you can find my email and my telephone number. So the intent of the guidance document is to give a primer for those who are not familiar with PFP in road tunnels. Why is PFP-NET interested? Well, John already mentioned it. Tunnel fires are severe and akin to the industrial fires that other PFP members are familiar with. And also the hazards are becoming more similar. So the scope of the guidance document is the following. At the moment, only road tunnels are considered, but other types are also under consideration, for instance, rail tunnels. The focus is mainly on tunnels made of concrete, but parts of the document may also be applicable to other building materials. The focus also mainly on the road-bearing structure of a tunnel and added on PFP. And only legislation from the UK, France, and the Netherlands is included. The guidance document is divided in 3 parts. First part is an overview. The second part, the design phase is discussed, and the third part, the operational phase. So in part 1, the overview, the steps necessary to implement PFP in road tunnels is given. And part of the discussion is about the major incidents that happened in the past. A high-level implementation chart is given, examples of PFP, and it also discusses alternatives to PFP. Active fire protection is also discussed with an emphasis on fixed firefighting systems. In part 2 of the document, the design phase is discussed, and this part gives a more in-depth overview of tunnel structures, raw regulations, procedures, and guidelines, as well as risk assessment approaches. This part ends with fire testing of PFP. And in the third part, the operational phase is discussed, which includes installation of passive fire protection, maintenance, and possible repair. So for this webinar, we will discuss implementing PFP and give some examples from part 1. So in the guidance document, the following implementation chart is given. 7 steps. The first step is identifying the key tunnel characteristics. For instance, if a tunnel is located on land or maybe on the open water. The next step is to check relevant regulations and law. And based on that, a risk assessment study can be performed. So coming from the risk assessment study, the next step is to choose a fire protection system. And in step 5, test that system for conformity. So if the system does not comply, you have to go back to step 4. So after choosing a fire protection system, the system can be installed and in the end, maintained. So now we will discuss some common types of passive fire protection in road tunnels. There are actually 2 common types. The first one is a spray applied mortar, and the second one is based on fire-resistant boards. So at this moment, at the time of writing of this document, intumescent coatings are not in use, or at least I'm not aware that they are in use in concrete tunnel structures. But I also know that some developments are being made. So let's start off with an example of spray applied mortar. So in this picture, it's shown that spray applied mortar is applied to the ceiling, to the beams, but also to the wall. What we see on the ceiling is the surface that you get after applying spray applied mortar, which is a quite rough surface. But on the wall, the spray applied mortar is troweled to cut down the unevenness and to give it a smooth, appealing surface. And the wall is also painted. Next up are examples of fire-resistant board systems. Starting off with a post-fixed fire protection board system. So with post-fixed, we mean that the system is installed after casting of the concrete structure. Sometimes fire protection boards are cast with the concrete, and in that case, we refer to it as a prefixed system. So this particular system has the back of the boards in contact with the underlying concrete, and the boards are fixed with stainless steel anchors. And these boards are simply butted against each other at the joints. So such a system can also be painted to make it more appealing. One of the disadvantages of the first system that I've showed with the butted joints is that high temperatures may develop at the joints, and these high temperatures may induce fire-induced spalling prematurely. So to get rid of that, sometimes strips are used to cover the joints. So in the left picture, front strips are used. So these are installed at the side, at the tunnel side. And in the right picture, backer or backing strips are used. So they're actually installed behind the main boards. There's a difference between these two systems in the sense that in the left system, the entire board is in contact with the underlying concrete, and in the right, the back of the boards are not in direct contact with the concrete, and that may have an influence on the behavior of the system. So board system may also be used to protect board tunnel segments. So the segments they are used with the TBM tunnels. So in this case, a faceted system is used, and the system is also placed on backing strips. And again, there is a void behind these boards, so these boards are not in direct contact with the concrete. Another variation on the board systems is a system that's installed to a steel structure. So in this case, the boards are again not in direct contact with anything at the back. And sometimes that means that these boards have to be thicker to make them structurally sound during fire. And the last example is a system which has a decorative layer attached to it. So these are actually the same boards as we've seen before, but a thin layer of steel with a painted steel or is installed to these or glued to these boards to make them more attractive. And in this case, also a system is used so the anchors are not shown at the tunnel side. So continuing with part 2, design phase. So from this part, we only will discuss testing of passive fire protection systems. So testing may be divided in reaction to fire tests. So these results of these tests are mainly applicable to the beginning stages of a fire. Fire resistance tests, of course, and other tests such as froth-thaw cycle tests, fluctuating air pressure tests, and tests to check against resistance to chemically aggressive environments. Exposure and aging tests are mentioned in these EAD documents. So on the European level, no harmonized fire resistance testing standards or classification systems exist for PFP and road tunnels. So testing at the high temperatures that may be expected at the most severe tunnel fires. So actually every country within the EU arranges this on a national level. And the guidance document describes the procedures for France and the Netherlands. There's no specific UK procedure at the moment. Before we will continue with testing, we will first have a look at some fire curves that are used at these tests. So let's first have a look at the ISO 834 standard fire curve. That's actually a fire curve that's used in buildings. And if you compare this fire curve to a common tunnel fire curve, for instance, the RWS fire curve, we see that the temperatures at the RWS fire curve are much higher, with a peak of 1350 degrees Celsius at 1 hour. But what's also of interest is that the tunnel fire curve have a much higher rise in temperature in the beginning stages. So for instance, the RWS fire curve goes in 5 minutes to 1100 degrees Celsius. And that may have an influence on the behavior of the concrete tunnel structure. So you have a rapid increase in temperature. It's more likely that you will have fire-induced spalling of the structure. some other curves. So the RDBS fire curve is used in the Netherlands, but also used worldwide. The HCM fire curve is used in France, and the area BT fire curves are used in Germany. So continuing with PFP in France. So in the French case, the PFP should have a European classification A2 S1 D0. For determining the fire resistance, SATU has published a guide called Passive Fire Protection Systems Justification of Performance for Road Tunnel Structures. And this guide is actually freely downloadable from the SATU website. In the SATU guide, a test is described that's based on the European test standard EN 13381-3. But the SATU guide substitutes the standard fire curve for a different fire curve. And it also describes more instrumentation than the European test standard. What's worth mentioning is that the SATU guide only describes a method to determine the characteristics of passive fire protection. So spalling properties of the concrete structure are in the SATU guide not considered. So this is an example of the fire curve that's used in the SATU guide. So actually, depending on the required safety level, different fire curves are used, or actually the length of fire curves differ. So for the most severe case, the safety level N3 case, you will have a fire curve of 240 minutes, of which the first 120 minutes are the HCM 120 fire curve. And then after 120 minutes, it will pick up at the standard fire curve, the CN 240 part. And between those curves, there's a area to cross over from one curve to the other. Worth mentioning is that for these tests, a tensile stress in the low reinforcement bars is induced. So that differs from the Dutch case, which we see later, wherein a compressive stress is induced at the heated side. Compressive stresses usually have a negative influence on the spalling behavior of concrete. So no furnace pressure criterion in this case, and structural failure of the PFP system is not allowed. The fire resistance criterion is defined as a maximum characteristic temperature on the exposed surface of the concrete, and those are given in the technical specifications of the project. So the definition of this characteristic temperature is taken from the EN standard, but it differs from the Dutch case, from the effective RO 695 case. So continuing with PFP in the Netherlands. So in the Netherlands, a PFP system should have a BS2D2 classification as a minimum. And for determining the fire resistance, effective RO 695 is used. Latest version is the 2020 version. And this is again freely downloadable. This procedure describes two kinds of tests, a spalling test and a thermal insulation test. So a spalling test is normally a project-specific test in which also a representative concrete structure is made part of the test. Such a structure may be either unprotected or protected with a fire protection system. At the thermal insulation test, only the fire resistant properties of a fire protection system are considered. So spalling does not play a role in this type of test. So when looking at the spalling test, a heated area of a minimum of 5 square meters is required for unprotected concrete and 8 square meters for protected concrete, so concrete protected with a PFP system. The thickness of the concrete slab or lining should be the same as in practice, or maybe limited to 40 centimeters. So the thermal insulation test is actually divided again in two different tests, a large scale and a medium scale test. So the large scale test has a heated area of at least 8 square meters, and the medium scale test has a heated area of a minimum of 1.15 times 1.15 meters. And in the 2020 version of the procedure, the medium scale tests may only be used for R&D purposes. So to give an example of a test setup, this is a picture from the Effectus RO695 procedure. And this is a configuration that's required. What we see here in the middle is a board with full dimensions. So it's not cut down in length or in width. And that's important because larger boards behave differently during fire tests, actually worse than smaller boards. So if you want to use full boards in practice, you should also include those in the fire test. What you also see in this picture is the instrumentation that's used. So behind the boards, in the concrete surface, thermocouples are installed to measure the concrete surface temperatures during the fire tests. But also thermocouples are installed at the joints and the special joints, right? The T-joints and the X joints. So at the joints, the temperatures may be higher than behind the full board. So for the Spalding test, a compressive stress level should be maintained, which is representative of the conditions in the tunnel, because those have an influence, a negative influence on the spalling behavior of the concrete. But also the concrete mix, reinforcement, etc., should be representative of the actual situation. And for the thermal insulation test, only the thermal properties of concrete are considered. So in this case, there is a furnace pressure criterion of 50 pascals. And again, structural failure of the PP system is not allowed. So this is again a picture from the procedure, which gives criteria for a fire protection system. So normally a maximum temperature is required of 380 degrees Celsius on the surface of the concrete and a maximum temperature of 250 degrees Celsius at the first structural reinforcement layer. So next up is an example of a test on a concrete slab, and in this case, an unprotected concrete slab, so no PFP was installed. This slab has a length of 5 meters and a width of 2.4 meters and a thickness of 40 centimeters. And the heated area had dimensions of 4 meters by 2.4 meters, and the slab was only supported at the ends. The slab was installed on our large fire resistance furnace, and a compressive stress was induced in the slab using this blue loading frame. And for this test, a 10 megapascals compressive stress was used. This is a picture from inside the furnace showing the underside of the slab before the fire test. And this is the result after 25 minutes of RWS fire curve. So spalling in this case was so severe that we had to stop the test prematurely. So this test actually had to run for 2 hours. So this is again a picture giving an overview, the amount of spalling. And this picture gives a more detailed view of the surface. You can actually see here that spalling was so severe that it's actually behind the first reinforcement layer. This particular sample had a concrete cover of 70 millimeters. So With this test, we've lost in 25 minutes at least 70 millimeters, and at some locations even more. So this test really shows that if you have concrete that you test with a high temperature fire curve, as the one you would expect in a tunnel, that spalling might be so severe that your actual structure will be, let's say, eaten up by the fire. So this specimen definitely needed to be protected by a passive fire protection system to mitigate that. And this is a picture from inside the furnace showing how much concrete came off in 25 minutes time. This is another example of a test that we do at Effectis. This is a test on a bored tunnel segment for a TBM tunnel. And in this case, we not only apply a horizontal force with the blue loading frame, but also apply a vertical force with the red loading frame. Sometimes it's not possible to perform a test at our lab, and then we can go with our mobile furnace to the actual concrete tunnel structure. So for that reason, Effectis developed a mobile furnace. We have called it Mobifier, and we can perform tests on the wall or the ceiling of an actual tunnel. So the mobile furnace has a heated area of 1 by 1 meter and is able to reach the high temperatures of all the fire curves that we've seen before. So also the RDS fire curve, which goes in 5 minutes to 1100 degrees Celsius. So the mobile furnace is not only limited to tunnels, but we can use it at other sites as well. So maybe to get a bit of a closer view, this is a test on the wall. And you can see here that the mobile furnace is a self-contained unit. So here we have an example of a test on the ceiling of a tunnel. So heated area was 1 by 1 meter, and the actual box that we use has dimensions of 1 by 1 meter with a depth of 50 centimeters. And the burner that we use is a propane fired burner with a heat output of a maximum of 400 kilowatts. And we bring the furnace to the ceiling with a forklift. So from part 3 of the guidance document, we will not discuss any topic, but you may read that if you want to in the guidance document. So we've now come to the Q&A section of this webinar.
Thank you, Jos. And we have a number of questions in the chat. I'll try and summarize it. Basically, 2 people have posed questions, but for those of you on the call who are inspired to ask additional ones, we do have almost 20 minutes for Q&A, so please think about it. First question is from Nimish. I hope I pronounce it correctly. Basically, it's 3 questions, and maybe to start with the first one. EV fires and tunnels will have multiple mini blast effects, I assume. Has Effectis made a fire test regime to test blast resistance in combination with fire?
No, I think maybe Talal can also comment on this, but that at this moment is not something that we have done research into. And we also not made a specific fire curve or designed a specific test to see if that might be a problem with the concrete tunnel structures used. That's a problem with concrete tunnel structures. But that's the case for the Netherlands. Maybe Talal, you can maybe comment it. Maybe you've done it in the UK.
Not yet, but as I mentioned in my presentation, it's something to consider in any further research. Today we developed our prop tunnel, so hope we will be able to merge all this tests together to answer this question.
Thank you, Talal, and thank you also for the question, because this is basically what PFPNet tries to do, to look into, say, multiple risk scenarios like fire and blast or a cryogenic spill and a fire. So this is certainly a topic we can take into consideration when taking the tunnel subcommittee forward. So fire and blast or any other combination of fire and some specific incident scenario. So thank you for that question.
I totally agree with you. Is it very important that what we are doing today, we are trying to understand the impact of a fire happen in one occur, but later we need to imagine that the city have plenty of car running in different kind of fuel. So for that, maybe I raised that question to consider it for the further investigation.
Yes, thank you. Thank you, Talal, also. Second question from Nimish is relating to spalling of concrete. It's a question about the particle size and weight of concrete to be considered as a threat. Would you like to comment on the threat of concrete spalling? I suppose the question is related to, say, personal safety of users in the tunnel, perhaps also of the firefighters.
All right, yes. So that's, I think, a question about, right, the spalling of concrete. So what I've seen is that spalling is quite violent and explosive. So what I've seen in terms of particle size, it's in terms of 5 to 10 centimeters sometimes, or bigger. So that poses a serious threat if it comes off a concrete structure and it maybe hits someone. That's definitely a problem, especially for firefighters, I think.
I would argue, Jos, that you may be long dead before you're hit by a piece of concrete. So the temperatures normally are in such a level that you might suffer from radiation or inhalation of hot smoke. So in general, I think the threat is not so much for users in a tunnel, rather than it is a threat for the structural stability and compartmentation. But yeah, you're right. Pieces of concrete might be small chips in order of magnitude of a couple of centimeters and possibly some grams. But I've done tests myself when I was still with Effectis, and I've seen pieces flying around the laboratory that weighed more than 10 or 15 kilograms. So yeah, that's certainly the violence that you were alluding to, that is going along with concrete spalling. Another question from Nimish before we go to...
If you just give me, I totally agree with you. I confirm that I was witness. It was not really fire resistant test. It was facade test. And we saw some pieces of concrete, maybe fly for 25 meters. And one of the pieces was more than 10 kilogram. And we stopped that test for a safety reason.
Thank you, Talal. Last question from Nimish before we go to other people that posed the question. Are there criteria on the minimum length which needs to be fireproofed as a guidance, since access in both ends or portals is available? And there are also cross passages in tunnels. So is there any recommendation as to the length of the tunnel that would need to be protected?
I think normally the tunnel is protected from end to end. I'm thinking minimum length.
Yeah, I suppose that the question could be interpreted like, is there any difference between protection levels, say mid-tunnel or near the portals, so the entry and exit portals?
Yeah, there might be a difference. I know that for the in the middle of the tunnel, the RDS phi curve might be used. But at the ends of the tunnel, which is a more open situation, the temperatures might be somewhat lower, and sometimes the hydrocarbon phi curve is used for the exit and entrance of the tunnel. That's still a phi curve that rapidly rises in temperature, but the maximum temperature is less.
Area for submerged road tunnels compared to normal standard land tunnels? Was there a difference between, say, land tunnels and underwater tunnels?
There might be a difference in terms of the time. So in the Netherlands, tunnels under open water should be fire resistant for at least 2 hours, and for land tunnels that is only an hour. So that is a difference. In terms of fire curve, there is not a difference except for that the curve is longer and shorter in time. And for the criteria for the concrete, that's actually the same between tunnels underwater and land tunnels.
Okay, thank you. Another question from Nimish related to spalling. Is dense concrete more susceptible to spalling than less dense concrete using the same formulation or composition of the concrete?
Well, yeah, is it the same formulation? Then it would be the same density, right? So, but I think indeed that if the concrete is more dense, that is probably more susceptible to spalling than less dense concrete. I think that if you have a more open concrete, then it's less vulnerable to spalling than you have a very compact concrete.
Yes, thank you. I would like to add to that even using exactly the same concrete batch, that's an experience I know within Effectus. The casting direction, horizontal or vertical, might even provide some different spalling behavior. So even though you might have exactly the same composition and exactly the same casting and curing conditions, the casting direction itself, horizontal or vertical, might already lead to significant difference in spalling behavior. So it's rather complex, and it's difficult to find, say, a general composition of the concrete ingredients that would be more or less susceptible to spalling. So another question from Patrick. Within the experience of Effectus, have you come across any concrete mix for tunnels that was resistant to spalling, which is a bit building upon what we just discussed? So
Yes, I think that's a good question. So I'm thinking for the laboratory tests, I've not come across any concrete that was resistant to spalling, at least not concrete that didn't have any PP fiber added to the mix. We have done some tests in tunnels, which show that those tunnels were resistant to spalling, but this was usually concrete that had other properties which are not so nice. For instance, it has a very open structure. It has a low compressive strength. Right, it's vulnerable to attack of the reinforcement because it's so open. So yes, maybe there is a mixture that is resistant to spalling, but it probably has properties which are not so desirable for other things that you want from the concrete.
yeah, like castability, flow of the concrete, and so forth. There's two other questions. I'm looking at the time. There are some other questions coming in, so we may not be able to completely address all of them, but at least two I would like to put to you, Jos and Talal. One is from Bill Connell. Can you comment on the variances, the differences between the US standard ASTM 3134 versus the Effectus protocol R0695? Thank you, Bill.
Well, I do not know all the differences by heart, but I know that there is a difference in the size of the specimen. I think that the HTM uses a larger test specimen, or requires a larger test specimen. When you compare it to RO695, doesn't mean that the RO695 uses a small specimen, but the HTM standard even requires a larger specimen. I know there is a difference in the furnace pressure criterion. I think the HTM uses 20 pascals, whereas the RO695 uses 50 pascals. But those are the differences that I know by heart. So maybe, Kesa, you're more familiar with the HTM standard, because those were the differences that I know.
I would need to look them up as well, but I was thinking indeed of the same things as you said. So test specimen size and furnace pressure. I think in terms of heating curves, it's converging, if not the same. And maybe also in terms of instrumentation, so position of thermocouples and stuff like that, and maybe other criteria related to furnace control. So temperatures not only in the test specimen but also furnace control. So we would need to come back to you, Bill, with more details. And maybe a final question before we close. There is at least a question we got this morning as well in the morning session. Why does the guidance not consider intumescent coatings yet? And is that planned for the future?
Well, it doesn't include intumescent coatings because what I've mentioned earlier, I'm not aware of a product that's at the moment available on the market that can be used in the tunnel. Is it something that we would consider for future guidance documents? Yes, of course. We will look into that. And what would be the timeline? I don't know what the timeline would be. I think that first we would need a system that actually can withstand such a fire. And after that, we can include it to the guidance document.
So yeah, I suppose Effectus is certainly open to test any system that is out there to provide any passive fire protection. So, and as I interpret your answer, it's lack of proper, say, market availability of such products to be tested. So, yeah, certainly a topic of interest as well for future developments in the Tunnel Committee. And we would certainly, I suppose, welcome new members in the Tunnel Committee, but probably John will be addressing that as well. Maybe a last question again from Nimish. It's related to the minimum tunnel length. It's misinterpreted perhaps the first question, but it's about the tunnel length. Are there specific tunnels, short or longer, where perhaps passive fire protection need not to be considered, like a viaduct, for example? So if apparently in India there's a length where passive fire protection in tunnels need not to be considered. So is there a relationship you know of, or reasons you can think of why tunnel length is important to consider?
I think it also mostly depends on the legislation. But if you should consider it as a tunnel or not. But from a technical point of view, I think that is something that should come from the risk assessment that you've done. It might also be dependent on the environment that this tunnel is in. If you need to fireproof it, I think it's a difficult question to answer, right, within the scope of this webinar. I think normally for tunnels, I think in the Netherlands, shorter than 250 meters, we will not consider it as a full tunnel.
Exactly. So it's all about the risk of, say, collapse of the entire structure. If it's like a an aqueduct. You could also consider that as a tunnel, but you would perhaps think twice about putting any fire protective measures underneath such an aqueduct, unless you want to make sure that the aqueduct stays upright. So yeah, that all depends. It's case specific.
Indeed, yes.
All right. I suppose we're reaching the end of the webinar, and I suppose, Jos, Talal, we give the floor back to John from PFPNet to make some closing remarks. And thank you for those posing questions and your interaction in the chat. Thank you.
Yes, thank you.
Okay, thank you very much. Well, yeah, to our presenters, thank you very much indeed for those interesting presentations, and to Kees for doing that chat moderation. I just out of interest, with a background in intumescent coatings, it's interesting to hear that come up twice, this morning sessions and this afternoon session. I'm fairly confident you could find an epoxy intumescent that would go through tunnel fire testing, but I think the biggest problem with intumescent materials would be cost comparison to cement-based materials. But it would be interesting to dig into that one a little bit further. Anyway, just to give you what we're going to do from here, everybody who signed into this webinar today will receive a copy of the guidance document. I think you'll find that a very interesting and comprehensive piece of work. As some form of payback, we'd like to ask you, if when we send that out to you, we're going to ask you to give us some commentary on future work you might like to see PFPNet do on fire safety in tunnels, and that would be of great interest to us. You will also have the opportunity to ask some further questions. So in the communication you'll find my email address that you can come back to with further questions to me, and I will then distribute that to the guys here, and they will come back with answers to you to those questions. And finally, PFPNet has its conference in October on the 21st and the 22nd. So we're really interested if anybody has any particular subject matter paper that they would like to think about presenting at that conference relating to tunnels, tunnel construction, safety in tunnels, etc. We would be very keen to hear from you. So if you're not already a member of PFPNet, please take the opportunity to go to pfpnet.com, take a look at membership opportunity. It is there. We would like to have numerous companies join, of course, because what we find with PFPNet, the more diverse the companies we have involved, the greater the information we can draw upon, and the better work that we do in terms of output, etc. So I would encourage you, if you're not already a member of PFPNet, to take a look at that. And thank you all for attending. And again, once again, thank you to our presenters. I hope you've enjoyed this session, and we will be back in contact with you, as I said, and we look forward to your further comments. So thanks again to all. Thank you very much. Bye-bye.
Thank you. Thank you very much.
Thank you.